So let's go try. This is our first taste of any AP questions that go with this topic. You're going to find the multiple choice to be easier than the norm usually for this topic, and then the FRQs tend to be a little trickier for this topic. So, but when you're taking your first BC practice test, you won't get to a series question and be really stressed out about it because they're pretty straightforward, and you'll have about 6 or 7 of them, to be honest. There's a big, like I said, it's our fourth big idea. So it's of the purple, we're in all of this right now. So it's a good, huge chunk gets tested. Multiple choice tends to be easier. So go ahead and see if you know enough about those series tests to answer these two multiple choice. I'll give you a little bit of time. Remember, with multiple choice, we like accuracy first and foremost, but speed second. So if you don't need to write stuff down, don't. If you just know, don't run a test. So most of you are done, but I'm just going to talk for a little bit. So today we're going to learn a 7th test. So no, an 8th. We've done 7 of them already, right? So we'll do one specific test. I could probably have done it in one day, but I'm choosing to let the error off of it until tomorrow, because it's going to be a test that has error associated with it, and that gets tested almost always in an FRQ. So I'll show you that how it goes. But alternating series error is pretty common. So I'm just going to make sure we hit it really well, and I go slow tomorrow. So let's talk about just analyzing these. This is obviously a series question and not a limit, derivative, or integral, although most of our series questions do have limits in them. But this is testing which of our series convergence tests. What are they actually crossing off the box for having tested? P-series, yep. And it's usually a couple of these combined in one. This is actually testing P-series. So in order to converge, we need the exponent to be what? Greater than 1. So P would have to be greater than a half, correct? Just knowing one of the series gets rid of this guy, and this guy. So I think I saw Kaya crossing some stuff off after I'm like, okay, now even if you didn't know the other one, at least we're guessing between 2 instead of, well, you guys, it'll be down to 4. This is an older one. But this guy right here is checking off which box of the purple. I just was able to, if I'm writing for College Board, I'm like, okay, we took care, and that's what they do. They make sure everything in purple and blue is tested on your entire exam. That's so multiple concepts get kind of linked together. So that's geometric, and for geometric to converge, the absolute value of the common ratio has to be what? Less than 1. So this would be C. All right, how many of you had that right? Shouldn't have stressed you out a whole lot either, right? They're fairly straightforward with the amount of detail you've been putting into the tests. The multiple choice tend to be sort of straightforward. Also, with the amount of detail I've been making, I'm looking for my red marker. Do you guys see it? Oh, here it is. For the amount of detail I've been making you put on your series convergence explanations, you don't need any detail here because it's multiple choice. So it makes you be able to go with your gut as long as you're 100% sure. I am 100% sure this does what? I am. I've got a very powerful function family on the bottom and a smaller power function family on the top. Now, if I went like this, and I kind of do some paired, and maybe even throw an ln down here to kind of get that bottom going a little bit more. Now I don't know. All right, but then you do more. This is actually trying to test you on the ratio test, which is what you're going to learn on Friday, but you don't need it, correct? This guy doesn't need a test. I'm 100% sure it does what? It goes bananas. So totally. This guy, although they're trying to test a test, I'm seeing an n because constants don't really do much for me, and I'm seeing an n cubed. I'm really seeing 1 over n squared. I don't need to formally compare it to it with one of the comparison tests because I know it does what? Converges. So they're trying to test 3 different convergence tests, but notice I really didn't need to run any because I really get what they're all about. It's about who has more power and where that is. So which one am I here? D, right? Did you guys get both of those right? Yeah, so the multiple choice, you're not going to be going, what? But like I said, the FRQs, I'll bring one up, and I think it's one I've talked about, but I'm going to move to the next page of it today so you can see it. So first of all, the learning goal, I need to make sure by the end of the hour you know how to recognize an alternating series. You don't recognize it incorrectly, and then you need to know if it converges or diverges and how to write it. But it's a pretty basic test, so it's a pretty easy day today. First of all, I want to make sure you understand when I'm going to say a bunch in the notes in the presence of an alternator. I want to make sure you understand what is an alternator and what isn't. This is an alternator. When I put in a 1, it goes negative to positive. Negative, positive. It's not an oscillator, it's an alternator. It causes things to go from positive to negative or conversely on consecutive terms. Does that make sense? This is also an alternator. When I put in consecutive n values, it'll cause my series to go positive, negative, positive, negative, positive, negative. This is not an alternator. It looks like one. You'll be deceived by it, but it's not an alternator. It's actually just a number. What number is it? 1. It's negative 1 squared, which is 1 to the nth power. So it's 1 no matter what, and it does nothing. It's a multiplier of 1, and it really need not be there. But kids would sometimes confuse that for an alternator. Do you get why? Now, if I go like this, is it an alternator? Yes. So sometimes you're going to have to check to see if it's what I would call a viable alternator. Okay, so I'm going to go back to this. This isn't an alternator. Now I'm going to put up what I call the sneaky alternator. All right, it's one that does cause with consecutive value. What? Odd. Sorry. Yes, it wasn't a viable. I should have put a +2. That was my mistake. So the cosine n pi one. Do you see why that's an alternator? Put in consecutive numbers like 1, 2, 3, 4. What does cosine bounce between? 1 and -1, right? So it will cause sign changes on consecutive terms. This is what I call the sneaky alternator. So sneaky alternator can sometimes get skipped over because we don't see that -1 to a power. So that's a sneaky alternator if you can't read it. All right, so what does this series tell us? It tells us that if you do what you should always do when you look at a series, which is to in your header on paper take a limit, right? But up until now, when we've got a 0 that pops out, that's when you should have yesterday on your little quest launched into another test, because that's inconclusive, correct? What this says down here, so I'm going to try to explain all this to you, is that if in the presence of an alternator, that's what that means, right? So if you see one of these or the sneaky guy, right? If you take the limit without the alternator, that's what this means right here. So if you remove the alternator and take the limit and it goes to 0, then as long as the rule of sequence was decreasing, which you can see by observation whether the terms are going down as you go, then what it says is you can conclude convergence. It means that the alternator, if the limit goes to 0, will cause it to go fast enough to converge with that subtraction going on in there. Does that make sense? So here's what it says. It does not say, though, that if it doesn't equal 0, we diverge by the AST. This is a one-way test. A one-way test for what? Convergence. You'll be able to tell me if it diverges, but you won't be able to have your reasoning be by the AST. The AST is a one-way test for convergence. All right, so let me repeat right in here. So like if you make your study guide and all you do is copy all these boxes down, as you're explaining of the test, I'll probably give you 9 out of 10 homework points, so that's really not going to help you. All right? It's basically when I either rewrite or I'm talking about what they really mean, that's what I'd get in your head and write it down like in your own words. So what is this? Let's see if we can piece apart what I said. What did I say you're going to do right off the bat? What you've always done. You're going to, in your head, take a limit, right? And up until now, once you've taken that limit and it did go to 0, you didn't even write it down because you're like, oh, limit goes to 0. But if it didn't equal 0, what did you write? Diverges by our other one-way test, the nth term test for divergence, correct? But now, if you take the limit and it equals 0 in the presence of an alternator, whether it's what I call like let's put a viable alternator. Do you know what I mean by viable? It could be the sneaky one, or it could be like an in-your-face -1 to the n, but it has to cause those signs to alternate from positive to negative. So if your limit is 0 in the presence of an alternator, you can stop and definitely conclude convergence. Then this would imply, let's just call it S for series, converges by the AST. The AST is a one-way test for convergence only. You will never tell me something diverges by the AST. You're going to be able to conclude that it diverges, but not by the AST. Watch. So the first thing you're going to do is what you always would have done. You're going to, in the absence of the alternator, so you're going to not even look at that right now. It's a viable alternator. What do I mean by that? It's not just that it has a -1. It has a -1 that's going to what? Yeah, it's going to cause that sign change. All right, and in my head, I'm going limit as n approaches infinity equals a half. Exactly. Diverges by the nth term test for divergence. There, we're nodding, right? So I can't conclude it diverges by the AST, but I'll go limit as n approaches infinity of my rule of sequence is not equaling 0. It's not because it equals 1/2, it's because it doesn't equal 0, right? Therefore, if you didn't write this on your little test yesterday, the not equal 0, did I take points off? What do you think? Well, what do you think I did? I did. Totally. It's not because it equals half. Yours are graded. They're not on my computer or in my paper book. The other class isn't done yet. So they're kind of like, yours are done though. Anyway, so therefore, we'd say the series, let's write S equals, diverges, but not by the AST. What are you going to write? By the nth term test. And it's actually the nth term test. I liked it when some of you wrote for divergence. It actually is called the nth term test, but that kind of, if you write that, you kind of get it into your head. I had one of you who said something converged by the nth term test. That can be deadly. So, but it was only on one, so it doesn't affect the, like instead of maybe a 24 out of 25, you lost all 3 points, so you got a 21. It didn't fail you, but it's a big chunk because I can't give anything for it, right? So be careful with that. You will never write that something diverges by the AST, all right? So the next one up here, do I have a viable alternator? Yes. Am I 100% convinced that that limit is 0 or not 0? I'm going to say no, because I do have 2 different function families, and natural log is weaker, but I'm kind of pulling on it in here a little bit. So although my gut tells me this probably goes to infinity, because I don't think it, but I would, like this everybody knows is a half, and you don't have to. Let's suppose it's FRQ. Are you ready? And there's usually an alternator somewhere in an FRQ. I would do this, that the limit as n approaches infinity of the top is what? Infinity. If I was doing an FRQ, I'd go like this, because what rule am I going to need to use to convince myself what the limit is? I am. I've got this infinity over infinity, and I'm not quite sure how close they are, right? So I'm going to do limit of the denominator, which also eventually goes to infinity. I don't know if it's going, fast enough. My gut says no. All right, so let's go take a look. Then if you were doing an FRQ, what would you have to write? Therefore, by L'Hopital's rule, or I'm using L'Hopital's rule, somehow reference the rule just in case there's a point for it, but I'm just going to launch into it because I've told you guys that enough. Limit n approaches infinity, and the top would be the derivative of n. And the bottom would be the derivative of the natural log of u. So we have to remember our AB. What's the derivative of natural log? U prime over u. Yep, gone, gone, boom. We good so far? It's a nice easy test. So the limit as n approaches infinity will be of just n when I multiply by a reciprocal. Now I'm 100% convinced that this is actually going to diverge, correct? And that doesn't equal 0, so neither one of these first two did I reference the AST, right? I'm trying to use it and it's failing me, right? So what would I conclude with this one? Therefore, S diverges by nth term test for divergence. Perfect. Now watch the next one. I see a viable alternator, but what did I call the alternator in letter C? It's the sneaky alternator. A lot of times kids just look at the -1 and they assume it's always going to alternate. So I'm trying to get you to sort of make sure it's a viable alternator. Cosine does pop back and forth when you go from 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. It's going -1, 1, -1, 1. It's great. How about if I had sine? N pi. Yeah, 0, 0, 0, 0, right? There's one on your notes because somebody asked me, not on your notes, on your homework, that they were questioning me about last hour, and they said, what if it goes, because they weren't sure if it was a viable alternator, and I said, if you're not positive, you better start putting in consecutive values of n and convince yourself. And one of them on your worksheet's going to go 1, -1, 0, 1, -1, 0. Do you think that is a viable alternator? It's not, because 0 is not considered positive or negative, and it has to go positive, negative, positive, negative. Does that make sense? So they were asking me, well, what do I write then? I said, well, diverges. We could do nth term test because we had a big discussion about it last hour. I like to tell you guys because there's more of them, so I get more questions and stuff. But the question was, but I don't know what it equals. So I can't write equals number not equal to 0, correct? And I said, but why do you know it diverges? Because they did. And they said, well, because it's dinging around between 1, -1, 0, 1. I said, what's that called? They said, oh, it's oscillating. I said, so is it equaling 0? And they said, no. I said, so right, limit, blah, 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 does not equal 0. I said, that's what the nth term test for divergence says. If its limit doesn't equal 0. Why do I make, when you guys do it, do you have to calculate the limit and say equals a half does not equal 0? What do you think a point sometimes is on the AP test? It point for the limit. Exactly. Otherwise, you might just be saying, well, I remember that it's, but I don't know what it goes to. I don't remember L'Hopital's rule. So you do have to state everything possible is what I'm preparing you for a really good smooth FRQ. Multiple choice, right? That you just saw there, kind of easy. All right, so let's go take a look at this guy. A viable alternator, yes. Then what do? I take the limit in the absence of the alternator. So what I'm really going to do is get that alternator out of there. Would that go to 0? Yes. Notice without the alternator, it wouldn't converge. It needs the alternator. Do you get why? Without the alternator, what is that series? The divergent harmonic. But what this is saying is that sign altering is going to cause that subtraction to bring it closer to 0 faster and fast enough. So the only time you get to conclude converges because the limit is equal to 0 is when it's in the presence of a what? Viable alternator. So it's sort of a tricky test, but you can just go like this. Therefore, by the way, are you convinced that these are decreasing? Yes. I mean, so usually that second criteria up in that box, you're just going to look at it and you might see like if you look in the back of the book, it might say with a sub n less than a sub n plus 1. That's what they're saying is we're decreasing as we go. Yes? No. I've never seen that have to happen. So anyway, so this would be, therefore, S, right, converges by what test? By the ACT. So notice the first two I gave you, AST, ATS. The first two I gave you, I was trying to do the AST because I saw an alternator, but my conclusion didn't reference it. So let's go to the next page and have a little whirl on here. We won't write all of these out nice. If it's multiple choice, what does D do? Converge or diverge? Oh, totally. Oh, and fast. So I don't, whatever. But if I have to explain it in the presence of an alternator, and it's a good one, right? I will take the limit as n approaches infinity of 1 over n factorial. What does that equal? 0. Therefore, this converges by the alternating series test. So you don't need to write that if you don't want to. Let's go look at the next one. All right, I'm seeing an alternator, correct? So in the absence of an alternator, I'm 100% convinced that this also does what? Totally. It converges without the alternator, right? So the alternator is just going to make it go faster. All right, so this guy right here, I would say the limit as n approaches infinity of 1 over n, I'm removing, showing College Board, I'm going in the absence of an alternator, is equal to 0. So therefore, what would I write? S converges by the alternating series test. Easy. It didn't even need the alternator. Now look at letter F, because it's going to be what I talk about next. When I keep saying it doesn't even need the alternator, it gets a classification of one of these words, which is also one of the things on this purple checklist, and you will also be asked. Yes? Without the alternator, you could go there, but this is so great for alternating series because it's shorter. You don't have to write to what you're comparing it to. So yeah, I guess if you explained your LCT or DCT, fine, it'd be fine. But this one's short and sweet when it works, right? So let's go look at letter F. In the presence of a viable alternator, yes. Does the limit of the rule of sequence go to 0? Yes. So therefore, that converges by the alternating series test, but it needs the alternator. What do I mean when I say but it needs the alternator? In its absence, I'm looking at the what? Divergent harmonic. So it actually needs that every other term being a minus to pull it to 0 and have it converge. So that's what, when I keep saying it needs or it doesn't need the alternator, why are these highlighted? You do, and they'll be on my test, and they're actually also a double hit. My test and AP test will reference absolute and conditional convergence. To explain it with all of this, I think I'm going to explain it with the words first, and then we'll talk about it. So notice all the words about it. Down here, what does this mean? All right, let me tell you what it means first, and then we'll go back up there. So really what it means is if Elizabeth sees an alternator, right? And she starts running the alternating series test. So it means if, right, the limit as n approaches infinity of your rule of sequence without the alternator. Now, what math symbol would replace without the alternator? What would kill an alternator? Absolute value. That's why you're seeing absolute value bars in the that's the math. You see what I mean? So that's like the math notation for me saying in the absence of an alternator, well, how do you mathematically kill that? You take the absolute value of the rule of sequence. So if the limit as n approaches infinity in the absence of the alternators, what I'm saying, right, equals 0, right? This means you can apply the test, right? And the series doesn't even need the alternator. Do you think we say it's absolutely convergent or conditionally? If it doesn't even need the alternator, absolutely, it's absolutely convergent. If it doesn't even need the alternator, it converges what we say absolutely. If you remove the alternator and you're looking at a divergent one, then you would say, oh, it needs it. So it's called what? Conditionally. It's a really easy question to answer. I don't know if I phrased it the best in script, but I think I said it really good. So I'm going to go to the next page and I'll get to your question in just a second. So now the additional to question is, if it does converge, you need to be able to tell me absolutely or conditionally. The problem is when that's a 50-50 guess. So Kaya could just guess and guess it right half the time. So guess what you have to do? You have to somehow justify why you're picking that. So they get kind of long to write out when that part's added to it. So let's write one out really well and the other one not. All right. So on this one, I'm seeing a viable alternator. I'm launching in to my alternating series test. So I'm going to look at that rule of sequence in the absence of the alternator, correct? And its limit goes to 0, so I'm done. I know I've got a convergent, right? Therefore, S converges by the what? The AST. However, now I'm asked to state if it's conditional or absolute, and I could just guess. So basically what that means, yeah, it's conditional. I need it. But you can't just write conditionally. You have to say why. Why does it need the alternator? The sum of the absolute value of it, or in the absence of the alternator, right, alone, does what? Diverges. Why? P series. Yeah, you guys are awesome. P series. You could write a divergent P series. My guess is that, again, these are guesses, but usually when I'm almost positive, I say my guess is. You probably wouldn't have to say because P is equal to 1/2, which is less than 1. You probably wouldn't need to do that. Actually, that should be less than or equal to 1. I took halvesies off for that on your little test too. The divergent harmonic, it does diverge when it's 1. Yep, a lot of you just put less than 1, and you lost a half. It's not a big deal because it was actually on the P series test. I don't think you have to put that here, though. You just say it's a divergent P series. But, so absolutely or conditionally? Therefore, it is conditionally. Now, this one I did as if I'm trying to earn full points in college credits off my AP exams. Conditionally convergent. You guys go ahead and write it. But let's assume B was multiple choice. And the option was diverges by the nth term test, converges absolutely by the AST, converges conditionally by the AST, or not enough information. Right? I just glance at it and I go, converges absolutely. So they're kind of on both ends of the spectrum. The multiple choice is like, sweet, and the FRQ, it pops up there and you're like, oh, but it's really not so bad when it's earning you 8 college credits, right? So just take the time. If you have to write it out, write it out. But again, why did I say, just in case you're like, what? Why did I just go like this? If you're listening to the notes, my back is to my board, and I turned and I said it's absolutely convergent. What did I see when I looked? I saw a geometric series in the absence of the alternator. It converges without it. So it's absolutely convergent. Do you think you have a good grasp of those two terms? Absolutely. So love the answer. So this is the next thing that's coming tomorrow. Error bounds tend to be an issue. So you know, we've done one kind. Okay, what error have we done? What integral test has an error that can be associated to it? Geometric series doesn't need one because we can find the sum exactly, right? Telescoping doesn't need one because we can find the sum exactly, correct? The P series doesn't, I don't know. So it's, although you like it, it just tells me converge or diverge, and I can't even get a window. Does that make sense? Unless I use the integral test. Do you get what I mean? Alternating series has a very definite error bound, and it makes sense. It makes more sense than the integral test error bound. So which one are you going to like better? AST, yeah. It's going to be actually pretty easy for you to understand why it works, and you're going to have an easy way to remember it. The integral test is not in the purple. The integral error. The test itself is, but the error for it is not. So what am I telling you when I say it's not in the purple up there? It's not tested on the AP exam. Don't say not tested, because do you think I'm going to test you on its error? I will. I didn't yesterday. I made a bonus, but I will make you know that. The reason I do it is, number one, it would be in a college course. Number two, it's harder than the other two you have to know. So by doing the harder one, I'm hoping it helps with the easier ones. Like usually kids would think alternating series test error is difficult, but because you already did one that's harder, what are you going to tend to think? This isn't so bad. There's a method to my madness. When I make you do things I know you're not going to have to do, it makes what you have to do easier. So how many kids got a 5 on BC last year, do you think? All but 2. All but 2, but they passed. But did I recommend all of them go on and take Calc 3? I did not. Some of them did anyway. But I said if you have an A in here and a 5, all right, because I give you some college level. I don't give it all to you, right? But I did have some who tried to move on, or they retook Calc 2. And what did I recommend? I would, because Calc 1's the one used in Calc 3. Does that make sense? And Calc 2 is the absolute hardest of all the calcs when you do it at lightning speed. What do I mean by lightning speed? They're done. They finished at Christmas if you were in college. Do you see what I mean? We are going at a snail's pace compared. So you got to be careful that you're not, number one, you know it and understand it really well. That's the AP test, testing that you get concepts. Number two, every time I say this would be on a college test, that you don't just gloss over it because I'm not testing. I don't teach college calculus. What am I teaching? AP, and there's a difference, and it's a great difference. AP, you have the concepts now. You understand what you're doing, but you haven't done them at a level all the time. Do you get what I'm saying? So, anywho, your assignment you'll finish quick. It is 1 through 9 only. It's not due tomorrow because we didn't cover the air, and I should have taken off my headset. Oh well, whatever. I'll take it off in just a second. I'll press that button. So we're going to talk through how I want you to write these. There's no back to it. I don't make you write 1,000 of them out. I'd rather you be able to write some of them really well. But this is what we decided last hour. All right, so I might as well keep talking in case somebody is absent and gets this off of Schoology. All right, so for 1 through 9, it says to use the alternate series test, alternating, I think it should say. That's a typo I've never noticed before. Use the alternating series test to determine the convergence or divergence. But if you say divergence, what test are you going to reference? Nth term test for divergent. We're going to add a direction on there because it's been added to your test. Since 2017, they've also want you to know. It's a new ad. Whether it's what? Absolutely or conditionally. But last hour I said write out the test really well. But you don't have to explain the absolutely or conditionally. Make sure you could if you had to. So let's do number 1, how you would get full credit. You're going to take the limit as n approaches infinity of what? 1 over n. It equals 0. Therefore, converges by the AST. Done. Does it converge absolutely or conditionally? It needs the alternator, otherwise it's the what? If you had to write it, you would say the series 1 over n, what would you write? Is the divergent harmonic. Now, those of you working are going to miss something. So one last thing, on the back, I want to talk about other divergent harmonics, which I never had. This guy, go ahead, flip your paper over. This guy is the, oh, why did I write an integral? Can you tell we're integrating in AB? Man. Yeah, you didn't even notice. Yeah, I've been like the AB and the BC, I bet, like, what did I do in 3rd hour? Oh, I said that the derivative, when I did that L'Hopital's rule, I said the derivative of this was 1 over n because we're doing u prime over u and AB all morning. And so I was like, they're like, what are you doing? I'm like, I don't know. Like the easiest derivative ever. And I wrote this, and I'm not lying. And I didn't even catch it. Like they're looking at me like I'm crazy, and I'm like, what? And they go, that's not the right derivative. I'm like, yeah, it is. It's u prime over u. And they're like, but it's not natural log. I'm like, crap, wrong class. It was actually really embarrassing. It was. Anyway, this is divergent because it's the divergent harmonic. When I throw a constant out front, 5n, or like a number 3, what did they throw out front? Go look at number 3. Isn't there number 3? There's a 3n, and then there's some constant tacked on. I'm going to write plus b. Anything in this form is called a divergent harmonic. It can be proved to diverge using the divergent harmonic. Are you nodding? What test would you run to prove limit comparison test? Yep, and you look at the quotient. What would the limit always go to? Yes, which is finite and positive. So this guy has to also diverge. So you can call this a divergent harmonic. So when you're doing number 3, does it converge conditionally or absolutely? You don't need to run a comparison test. Now, I just told you a common thing, right? Number 3, does it converge conditionally or absolutely? Conditionally, because it is a divergent harmonic. Do you see the difference? That's why I've always been saying the. Has it been bugging you that I say call it the divergent, like the divergent harmonic? Because I knew that it's a difference between the divergent and a divergent. And I'm picky. You're going to see it when you get your test back. I'm picky. Some of you wrote for the telescoping one, it equals 1/3 by the telescoping test. I'm like, but you didn't tell me if it converged or diverged. Oh, oh. I only took a halvesies off. I was like, that's fine. If you use the word converged. You did. Yep. Yep, I took that. Some of you just wrote it equals 1/3 by telescoping. I'm like, yes, but. I haven't put them in the grade book yet. I said your class is done. But just a second.